So here's the graph we're starting with today, okay? I'm not giving you an equation for it. I'm just saying this purple graph that we're looking at right here, this is f of x, okay? We're going to call that purple graph f of x. So the first graph, what I want you to give me is f of x plus 1. Now we don't have an equation, right? So what am I going to do with this graph? How am I going to get to the new graph? What do you think? Add 1. What do you mean by that? Where is the plus 1? It's outside the function, right? And we remember that outside means we move it where? Up, okay? So does that mean, even if I don't have an equation at all to look at, does that mean I can move every single one of these points right here up 1? So instead of being here, it's going to be here. Instead of being here, it's going to be here. Instead of being here, it's going to be here. Here is here. Here is here. And here is here. Done. Does that seem logical to you? It does, doesn't it? Because the 1 is outside the function, and we talked yesterday about if it's outside, what kind of change is it? It's a vertical change, right? So it's a plus 1, so we want to move it up 1. Well, what would f of x minus 2 look like? Which one are we moving down to? The purple one or the green one? Purple, because that's our f of x, right? So I'm going to start with the purple, and I'm going to move every point down 2. Hard or easy? Is it easier than you thought it would be at the beginning? Yes, why? Because it's something you've never seen before, and when you see things you haven't seen before, you freak out sometimes, right? But once we connected it to what we talked about yesterday, then you're a lot better, aren't you? Okay. Let's come over here. Same graph, right? Same function. I'm still calling it f of x. First, I would like f of x minus 1. Where's the change happening? Inside. So where are we moving this one? Left or right? Which way are we moving this one? Left or right? Why is it right? Because when it's inside, it's backwards of what we think, right? Okay, so it's inside, it's backwards of what we think. We think it should go left 1, but it's going to go right 1. So every single point that's here, it's going to just move right 1. How did this disappear? That's weird. Do I need to do one that's left 1 for you? Or you got that? What would it look like if it was going to move left 2? F of x plus 2. That's exactly right. And then every point would shift left 2, right? So let's jump to this one instead. 2 f of x. That's different, isn't it? Well, is it? Where is the change happening? Outside, so we know it's going to be what kind of change? Vertical change. And it's going to be a vertical change by 2, by a factor of 2, because the 2 is multiplying by the function, right? So think about it this way. How far did this one come down? 1, right? From here to here is 1, isn't it? How far should it come down now? 2, because 1 times 2 is 2. So 1, 2. How far did this come down? It didn't, did it? Because it's sitting on the axis, right? So I leave it alone. How far did this one come down? 1, so how far does it come down now? 1 times 2 is 2. So far we have this. This is what we have so far. Does it make sense so far? Does it look like I held on to this point right here and stretched it by a factor of 2? Stretched it twice as far as it was before? Yes, okay, good. So where does this one go? It stays because that's where it was before. Where does this one go? Well, where is it? Where was it before? 2 away from the axis, so where should it be now? 4 away from the axis. And then where does this one go? Nowhere. Think about it logically. Does it make sense that I held on to the points of the axis and took the rest of them and stretched them by a factor of 2? Any questions about that one? We good? Okay. So we have 2 more. Now on these it was okay for me to do 2 on each graph because you could really kind of keep them separate. They didn't really cross too much for what we needed. For this one, it's not going to be okay. So I'm going to need 1 on each of these graphs. Okay? So first one, let's do negative f of x. First of all, remember we are calling this as f of x. Our purple one is f of x. So for our pink one, let's call it negative f of x. So where is the change happening? On the outside. So that is a vertical change. Knowing what we know from yesterday, what's happening? It's a reflection across the x-axis, right? Now that would be a vertical change, wouldn't it? Isn't this a reflection across the x-axis? Okay, so think about where this point is in relation to the x-axis. Where is it? It's 1 below, right? Where should it be now if I'm reflecting it across the x-axis? 1 above. Where is this point in relation to the x-axis? So what do I do with it? Leave it alone. Where is this point in relation to the x-axis? 1 below, so I need to be 1 above. This point, leave it. This point, it's 2 above, so where does it need to be? 2 below. And then this one. So now let's just draw our new shape. Now, to me, it looks like a fish skeleton. I don't know why. And I also don't care if you don't think it looks like that. Or maybe like a stick fish. That doesn't matter though, right? What matters is, did I take the purple one and reflect it across the x-axis? Like if I folded this paper along the x-axis, would they be right on top of each other? Yes. Okay. Last but not least, let's do negative f of x. No, we just did that. Sorry. How about f of negative x? That's what I meant to do. So this one we were very clear that it reflected over the x-axis, right? What's happening with this one? Okay, over the y. So reflect over the y-axis. Now, does that match with the vocabulary we've been using? Because vocabulary-wise, what I've said is, where's the change happening? Inside. And if the change is happening inside, what kind of change is that? A horizontal change, right? Is this a horizontal change? It is, right? Okay, so instead of figuring out this way, we're figuring out this way, right? How far away is this from the y-axis? So if it's 2 to the left, where does it need to be? 2 to the right. What about this one? 1 to the left, so 1 to the right. What about this one? Well, it stays because it's already on the axis, right? What about this one? So 1 to the left. What about this one? That's 2 to the left, or 2 to the right, so I need it to be 2 to the left. And then what about this one? It's 3 to the right, so 3 to the left. Now, I don't know what that looks like. Does it look like anything to you? No. Did I take it and reflect it across the y-axis? So everything worked out, right? Okay, any questions so far? Just a couple more to talk about, but this time instead of giving you a graph, I'm going to give you an equation. Now, isn't this kind of what we did yesterday? So why are we doing it again? Practice, and maybe something's a little different that I want you to see a little different. Is that fair? You good? Okay. Basketball? Okay. Is Mr. Hassman going to be there at all? Are you going to be there at all? Okay. A little. I think it did okay last time. No. Okay. Okay. Yes, ma'am. What if I ask for f of x plus 1? Guys, what if I ask for f of 2? What does it want me to do? Instead of f of x, if I say, what's f of 2? What does it want me to do? Anywhere there's an x, yeah, put in a 2, right? So that's something we've done for a long time. You've done that all the way back to Algebra 1, right? Maybe even earlier, I don't know. But for sure, Algebra 1, right? So what if instead I ask for f of x plus 1? First of all, transformation-wise, like graphically, what's it asking me to do? Move it where? To the left 1, right? Because it's inside, so it's backwards of what we think, all right? But algebraically, it's asking me anywhere there's an x to put in an x plus 1. So anywhere there's an x, I put in an x plus 1. Do you see that I did that? That used to be x squared, now it's x plus 1 squared. That used to be an x, now it's x plus 1. That used to be a 1, there's no x there, so I leave the 1. Yes? Now, depending on the situation, you're done or you're not. Okay? If I ask for x plus 1, this is a perfectly fine answer for x plus 1. If it says, like substitute and simplify, then you need to go ahead and multiply these out. But I'll tell you on your homework tonight, you don't. You leave it just like this. So are you okay with me leaving it just like this in the notes? Okay? But you could multiply it out if you wanted to, right? Because you're pretty dang smart most of the time. What about if I ask for this? 2 times f of x. Transformation-wise, what is it asking me to do? Vertical stretch by a factor of 2, right? But algebraically, what is it asking me to do? Take the function and multiply by 2. 2 times x squared plus x plus 1. Again, that's a perfectly fine answer, isn't it? Could we go through and simplify it if we needed to? Yes. What about this? Negative f of x. What's it asking me to do? Transformation-wise. Perfect. Reflected over the x-axis. Okay. Algebraically, what is it asking me to do? Take the function, multiply it by negative. Absolutely. X squared plus x plus 1. Is that a perfectly fine answer? Could we multiply it out if we wanted to? Yes. God bless you. Let's see if you can do two things at one time. Can you? F of negative x plus 3. Algebraically, no, sorry, transformationally, what is it asking me to do? Reflect it over the y-axis, because this negative is inside, right? So that's a horizontal change, so that's over the y-axis. And then, somebody else? Vertical shift up 3, right? Okay with that? Algebraically, what is it asking me to do? Replace all the x's with negative x, and then add 3. So I'm going to replace all the x's with negative x, and then add 3. Now, this will bug people more than any of the other ones. I'll tell you that right now. Because people want to just add 1 and 3. Because that's too easy, right? It's too easy to leave it not done. So a lot of times in this case, people will say that's actually x squared minus x plus 4. They'll go ahead and simplify that one. A lot of times people will simplify this one. A lot of times people will simplify that one because it's what? Too easy, right? It's too easy to not simplify it. They don't want to do this one because they remember that x plus 1 squared is really x plus 1 times x plus 1, and they have to distribute. They can't just square both terms, right? They have to actually square the whole thing. But I'm telling you right now, these are all acceptable answers. I just went ahead and did this because I could see some of you like twitching because you wanted to go ahead and add the 1 and the 3. You okay with that? Any questions?